Welcome to ScienceCover.com. This session is on centre of mass. The aims of the session are to know what we mean by the centre of mass, how we can find the centre of mass using a plumb line, and how the centre of mass can affect the stability of objects. Before we begin, pause the video and complete the Do Now task. Let's check the answers. Number 1. This diagram shows a seesaw in equilibrium. Calculate the anti-clockwise moment. So the anti-clockwise moment, we need to take the force, 30 newtons, and multiply it by the distance from the pivot, 4 meters. 30 multiplied by 4 is 120 newton meters. Part B, what will be the clockwise moment? Well, this seesaw is in equilibrium, so the clockwise moment will also be 120 newton meters. Calculate the distance that child B is sat from the pivot point. So we know that the moment is equal to the force times the distance from the pivot. We know that the clockwise moment must also equal 120 newton meters. So we can say 120 equals 40, which is the force of the boy, multiplied by the distance. So if we rearrange this, the distance is equal to 120 divided by 40, which equals 3 meters. Now let's look at what we mean when we talk about the centre of mass. The weight of an object may be thought of as acting through a single point. This point is called the centre of mass. An object can be balanced on a support if the support is placed at the location of the centre of mass. This toy is able to balance on a person's finger, as the centre of mass is at the bird's head. The centre of mass of an object can be found by finding the lines of symmetry of an object. The centre of mass will always lie on a line of symmetry. So for instance, to find the centre of mass of this shape, I first must find some lines of symmetry. I then identify the point that they cross. So this is one line of symmetry. This is a second line of symmetry. And the point that they cross is my centre of mass. Now for this particular shape, there are other lines of symmetry. But all of these lines of symmetry all cross at the centre of mass. Here is another example. Find the centre of mass of this shape. To find the centre of mass, I must find the lines of symmetry and identify the point they cross. So here is one line of symmetry for the star. Here is another. Here is another. The point at which the three cross, I can mark as the centre of mass. It does not always have to be a mass at the centre of mass. This toy is balancing on point P, and to help find the centre of mass, we're going to assume that the connecting lines do not have a mass. So to find the centre of mass, we need to find the lines of symmetry and identify the point they cross. So this is one line of symmetry. Here is another, and here is another. And the point that these three cross is the centre of mass. But we can see that there is no substance or matter at the centre of mass in this particular example. Pause the video now and complete task 1. Let's check our answers. Number 1. What is the centre of mass? This is the point at which all the weight of the object may be thought as acting through. Use lines of symmetry to identify the location of the centre of mass for each of these shapes. At A, the centre of mass is in the centre of the square. At B, the centre of the mass is in the centre of the rectangle. At C, the centre of the mass is at the centre of the circle. In D, the centre of mass is in the lower central section of the triangle. And in E, the centre of mass runs along the middle of the arrow, but we can assume that it'll be to the right-hand side because this is where the arrow splays out. How to find the centre of mass using a plumb line? We cannot use the method of symmetry to find the centre of mass for all shapes. To find the centre of mass of an irregular shaped object, we can use a plumb line. Now, a plumb line is a mass hanging off a piece of string. The mass will always hang vertically downwards. This is useful as when any mass is hung, its centre of mass will align itself with this plumb line. Let's look at an example of how we could use a plumb line. How can a plumb line be used to find the centre of mass for this fish? The first thing to do is to pick 3 points that we will hang the fish from. It doesn't matter where these points are. Tie a string through one of the points and hang the fish from this string. Hang your plumb line from this point. The centre of mass will lie along this line, so mark the direction of the plumb line with a pencil. Next, tie the string through a second point and hang the fish from this string. Hang your plumb line from the point, and again the centre of mass will lie along this line, so mark on the direction of the plumb line with a pencil. We now have 2 lines and can see where they cross. This gives us the location for the centre of mass. But we can check the centre of mass using our third hole. Tie the string through the third point and hang the fish from the string. Hang your plumb line from this point, and the centre of mass should lie along this line, so mark on the direction of the plumb line with a pencil. Now we can see that all 3 lines cross at one point, so this must be the centre of mass. We can then mark the centre of mass with a cross. Pause the video and complete task 2. Let's check the answer. Explain how a plumb line could be used to find the centre of mass for this duck. First, make 3 holes in the duck. Hang the duck from one of the holes. Hold the string of the plumb line up to the hole and mark with a pencil the path of the plumb line. Now hang the duck from a different hole. Again, hold the string of the plumb line up to the hole and mark with a pencil the path of the plumb line. Then hang the duck from the third hole. Hold the string of the plumb line up to the hole and mark with a pencil the path of the plumb line. Where all 3 lines cross is the centre of mass. Let's look at how centre of mass can affect an object's stability. Imagine we have a double-decker bus. The centre of mass is represented by the cross. As we tip the bus, the centre of mass moves. The wheel is now acting as a pivot point, and we can draw a line directly up from this pivot point. This is the boundary of the base of the bus. If the centre of mass is inside of the base, then the bus has a moment or turning force that will pull it back onto four wheels. If the centre of mass is in line with the boundary of the base, then the bus will balance perfectly and not fall either direction. However, if the centre of mass is on the outside of the base, then the bus will fall onto its side. To make items more stable, designers use two tricks. The first is to have a low centre of mass. This can be done by reducing the height of the object. A shorter bus has a lower centre of mass and has to be tipped further to move the centre of mass outside of the base. The second trick is to make the base wider. This bus has been made wider. It is therefore more difficult to move the centre of mass outside of the base, which makes it more difficult for the bus to tip over. Pause the video now and complete task 3. Let's check our answers. For each of the images, explain what will happen to the bus and why. For A, the bus will fall back onto its wheels. This is because the centre of mass is within the wheelbase. In B, the bus will balance at this angle. The reason is that the centre of mass is in line with the boundary of the wheelbase. For C, the bus will fall onto its side. This is because the centre of mass is outside of the wheelbase. It is decided that the bus is not stable enough to be allowed onto the road and sent back to the designers. How should the design be altered to improve the stability of the bus? First, we can make the bus shorter. This lowers the centre of mass. Secondly, we can make the wheelbase wider.